Now that we've seen logging and checkpointing, we're ready to talk about actual recovery. So what happens when the system crashes? Well, the big picture is this. We're going to go to the master record and we're going to find a checkpoint from the master record. And then there's going to be 3 phases to our recovery protocol in ARIES. First is an analysis phase, which runs from that last checkpoint forward to the end of the log, and it figures out which transactions committed since the checkpoint and which failed since the checkpoint did not commit or aborted. We're then going to do a redo of all of history that isn't in the database. We're going to start from the smallest rec LSN in the dirty page table that we find after analysis. We're going to redo everything from there. We're even going to redo the CLRs. We're going to redo our undos that we were doing when we crashed. We're going to redo everything. And a key aspect of ARIES that makes it understandable and keeps it correct is this notion of repeating history. During redo, we're going to redo everything. We're going to redo the actions of uncommitted transactions as well as redoing the CLRs of undone actions. Okay? And by the time we're done with redo, we've pretty much got the database in the state it was in at the time of crash. Finally, at that point, we will undo the effect of failed transactions by working the log backwards from the end to the oldest log record of any transaction active at the time of crash. So 3 phases: analysis, which is forward from last checkpoint; recovery, which is forward from the smallest rec LSN in the dirty page table; and undo, which starts at the end and goes backward until we hit the oldest log record of the transaction active at the time of crash. Let's talk about the analysis phase first. We need to reestablish our knowledge of the state at the time of checkpoint. And so we're basically going to start with the transaction table and the dirty page table stored in the end checkpoint record, and we're going to figure things out from there. So we're going to scan the log forward from the checkpoint. Once we populate our dirty page table and transaction table from the checkpoint, we start scanning forward from the begin checkpoint record. If we see an end record in the log, we can remove the transaction from the transaction table and not think about it anymore. We know that transaction was fully taken care of. If we see an update record in the log, if its page is not in the dirty page table, well, it was dirty at that point. So we add it to the dirty page table and we set the rec LSN to be the LSN we're currently scanning. And if it's any other kind of record than an end record, including an update record or any other kind, we add the transaction to the transaction table if it's not there. We set the last LSN of the transaction to the current LSN we're looking at. And of course, if we see a commit record, we change the transaction status to committed. At the end of analysis, when we're done doing this process record by record from the begin checkpoint to the end, for any transactions in the transaction table that are in the committing state, we're going to write a corresponding end log record. These are transactions that we're going to commit, and therefore we can write an end log record to the end of the log. And we're going to remove that transaction from the transaction table. What's left in the transaction table after that are transactions that were active at the time of crash. They were either aborting or actually running at the time of crash. And these are the transactions that we're going to need to undo. The dirty page table at the same time also is going to say which dirty pages might not have made it to the disk.